Hello, I'm Godfrey from the Framework Core team. Welcome to the second half of the keynote where I'll walk you through everything that happened this year and how they might affect you as an Ember developer. I'd like to begin with announcing some personnel changes to the core team. This is not the whole core team, by the way. Many years ago, we used to be able to fit everyone on one slide, but we're way past that point now. You can find a full list of Ember core team members on the website, but for now, this is what changed this year. Isaac and Jared joined the learning team, and Scott joined the Ember data team. Kanipolo, as well as Matthew from the Framework Core team, joined the steering committee. And meanwhile, Melanie is alumnizing from the learning team and steering committee to focus her duties on the Framework team. Likewise, Tom is now a steering committee alumni but is staying on the Framework Core team, and Jen alumnized from the Framework team to focus on the learning team responsibilities. Finally, Krati and Alex from the CLI team, as well as Shiva Kumar from the learning team, have alumni as well. On behalf of the community and the entire core team, I would like to extend a warm welcome to all the new team members, and a big thank you to the alumni for the continued contributions over the years. Okay, so this is all for the core team changes. And we have a lot of ground to cover today, so I'm just going to jump right in and talk about the changes in the framework. Now, as always, a lot of the work went into behind the scenes things like maintaining the framework, and this year is no exception. These bug fixes and small improvements don't usually get talked about as much as the big features, but they are no less important in maintaining a healthy framework and a productive workflow for us developers. So I'd like to take a few moments to talk about some of them briefly. The first set of changes are post-release improvements to Octane. With the wide release of Octane and more usages in the wild, there were some occasional bug reports for the new auto-tracking system, especially in edge cases involving other legacy features. A decent amount of work went into debugging and fixing these issues and putting in place a better infrastructure so we can provide more helpful information when errors do occur. Also, as of the current beta, all the built-in components like link to and input have been completely rewritten using the new Octane paradigms internally. We also made a lot of improvements to the linter, to the template linter in particular. There's now a new to-do system that makes it easier to adopt new lint rules and migrate your code base gradually. A lot of the new lint rules also have auto-fixers that could apply suggestions automatically. Outside the framework itself, we also made a lot of quality of life improvements to the tools and workflows you use on a day-to-day basis. Notably, we integrated Prettier into the default stack so you can stop worrying about formatting your code and focus more on writing it and avoiding the subsequent bite shed with your team during code review. There are also some improvements to accessibility this year. The default blueprint now includes the Ember page title add-on, which encourages you to provide meaningful and descriptive title for your pages. And there's also a lang flag to the Ember new command, which explicitly sets the human language for your app's content. These changes together will help provide a better experience to users of screen readers and other assistive technologies. Finally, we also made some internal changes to the Embersource package. In the past, when you install an Embersource package from npm, what you get is essentially a pre-built file that you can run directly in the browser as a script tag all the way down to I11. With this change, the Embersource packages now just lose ES modules without being transpiled first for a particular browser. And your app is responsible for building it according to your own browser target that you have configured. There are a number of advantages to this. For one thing, even though the Ember 3.x series officially supports down to I11, most of you probably don't care for it. So by deferring the building of Embersource to your app's own build pipeline, you can skip transpiling those features like native classes if your browser targets otherwise support them natively. This can result in some wins in byte size and even some performance improvements in some cases. Another benefit is that we're now able to compile your templates differently depending on whether you're building for development or production. This allows us to leave a lot more debug information in your template without worrying about inflating your final bundle size in production. So all of these are just a few examples of what we worked on behind the scenes this year, and I would like to thank everyone who were involved in making these awesome improvements to the framework. Okay, so as much as it was a year for improvements, it was also a year of cleaning things up. Here are some of the deprecations we landed into the framework this year, and hopefully you won't actually run into that many of them in practice because a lot of them are targeting very old legacy features that are rarely used these days. Nevertheless, I won't go into too much details about them, and you can read about the deprecations on the deprecation guide. However, I would like to point out two things real quick. Number one, we have deprecated the pre-Octane configurations, also known as the Classic Edition. This means that after 4.0, all Ember apps using 4.0 and above will automatically be Octane apps, and the difference doesn't matter anymore. And second, the latest, the last batch of deprecations targeting 4.0 have landed into 3.27, which is currently in beta. If everything goes according to plan, then next release after that would be 3.28, and that release will have no more additional deprecations for 4.0. And 6 weeks after the release of 3.28, we will release version 4.0, dropping support for IE11 among other things. You'll soon hear about more of the 4.0 plans on the Ember blog soon, but that's the gist of it. Okay, so that's all for improvements and deprecations. Up next, I would like to highlight 3 major areas that we worked on over the last year. But before that, let's go back to this slide from EmberConf 2019. Here, Tom was describing how when individual features are developed and released incrementally, things might actually start to feel incoherent for a while. Over time, as more of the companion features are released, and as the documentation, tooling, and ecosystem start to catch up, then things will start to really come together. The idea of an edition is to declare that we have reached those peak moments of stability and big picture coherence, and that the features are ready for community-wide adoption. Now, with Octane released last year, we are starting to work towards the next edition called Polaris. And so naturally, we find ourselves iterating toward that pit of incoherence again, which is, again, perfectly normal. As I walk through these new features, just keep that in mind. It's not that the features themselves are particularly buggy, but you might find that, for example, the guides and the Ember Inspector are lagging behind in covering these features. And it might be a little bit harder to get answers on Discord just because of how new these features are. So with that in mind, if you and your team are not prepared to be an early adopter, that's totally okay. Just treat this part as a sneak peek into the future, and when we're ready to wrap up the next edition, I'm sure you'll hear about it from us again. But on the other hand, if you're eager to help shape the future of Ember, this is your time to shine. As the features are still being designed and experimented on, your early feedback are going to be really important in terms of influencing the direction that we're headed. And if you're looking for opportunities to contribute, then there are no shortages of things that you can help with right now. So with that out of the way, let's get to these highlights. It shouldn't be a surprise, but the first thing on my list is Embroider. By now, you've probably heard about it many times, but in case you skipped the first part of the keynote, here is a quick summary. Now, historically, the Ember build pipeline looks something like this. We take your app plus the add-ons you use plus Ember itself, run it through this custom black box, and the end result is something that you can run in the browser. Basically a script tag that you can drop in. Because the build pipeline in the middle is completely custom, and because the apps and your app and the add-ons you use can customize this build pipeline in numerous ways, over time, Ember apps became quite coupled to this particular build pipeline, and it's almost impossible to swap it out with something else. In the meantime, the wider ecosystem have converged on some de facto standards around how modern JavaScript codes should be structured and published. And a lot of modern tools have been written that play nicely with each other as long as these ecosystem conventions are followed. Now, we could duplicate these efforts and re-implement these tools and features inside our own build pipeline, but a lot of these problems are pretty low level and not particularly specific to Ember apps, and we would honestly much rather focus our energy on somewhere else that's like more core to our mission as a framework. This is where Embroider comes into play. It isn't really a single tool or as an end-to-end replacement for our build pipeline, but rather it started as a holistic rethink on how we can reorient ourselves into aligning better with the wider JavaScript ecosystem conventions so that we can let these existing tools do most of the heavy lifting for us and we can benefit from these shared efforts for free. With that in mind, Embroider is a bridge that tries to take the collection of things that make up an Ember app, but instead of building it directly for the browser, it just transformed them into the de facto standard that is understood by most of the modern tools. And from there, you can you can use any off-the-shelf tools such as Webpack to finish the job. Now, in this example, I've shown using Webpack to build for the browser, which is going to be the default when Embroider is enabled for new Ember apps. However, Embroider itself is not dependent or coupled to Webpack per se. Its job is just to build things into the standard format, and in fact, in the future, as browsers start to implement native support for these standards, like native support for loading ES modules, you might not even need that final step, and you might be able to just take that standard output and run it in the browser directly without further processing. On the other hand, you are not limited to building for the browser either, because the output of Embroider is the de facto standard JavaScript code. You can also take that and feed it into other tools that understand those conventions, such as a dependency analyzer or maybe a documentation generator. As long as they follow the same ecosystem-wide non-Ember specific conventions, it will work. Now, if you want to read more about how it actually works beyond this very high-level overview, I recommend checking out the README on the Embroider repository on GitHub. And finally, I would like to give you a rough sense of where we are at with this initiative. Over the past year, we have merged the RFC that underpins the whole project called the add-on v2 format. We have also tested Embroider compatibility layer against a number of open source and closed source Ember apps, and along the way we fixed many issues that popped up in many popular community add-ons. Starting in EmberCLI 3.27, which again currently in beta, there will be a command line flag for generating a new apps using the Embroider blueprint. At this point, we are also nearly ready to release 1.0 of the Embroider package itself. If it all goes well, we might be able to make Embroider the default for new apps starting as soon as EmberCLI 3.28, which would be the release after this one. Therefore, if you're an add-on author, this would be a really good time to add Embroider to your CI config and make sure your add-on can actually build on it without issues. You can find the instructions linked from the README that I mentioned before. And if you're eager to test building your app with Embroider, you can also find the instructions in the README as well. At this stage, the top priority is compatibility and a seamless transition, so we're likely going to stick with the more conservative, more compatible configurations. However, as more of the add-on ecosystem have adjusted to comply with the stricter settings on Embroider, you will start to see more and more benefits and better results from optimizations such as tree shaking, which remove the unused part of the dependencies from your final bundle. So in summary, I think we're pretty much ready for prime time, and It's a long time coming, and I'm really excited about the future that it unlocks for us. Okay, that's all for Embroider. And up next on my list, I have a feature called name blocks. For this, let us look at an example scenario. Let's say you're tasked with implementing this fancy drop-down component at work. It's pretty similar to your standard HTML select element, except it supports richer HTML for the options, like you can have images and stuff inside the drop-down menu. So after staring at it for a while, this is what you came up with. All right, so let's walk through this together. First, you have a button on top that toggles opening and closing the drop-down menu, and then that's the markup for the drop-down menu itself. The component takes an add items argument, and there's a each loop to go through every item in the array. It then renders each of them inside the drop-down menu, and so that's how you get the results on the right. This is all great, the component works, but there's one problem. Currently, this drop-down component hard codes the markup for the menu items, which means that it will only work for this exact scenario, like these exact objects, and you cannot reuse this in another place where you want the menu items to look slightly different. Perhaps you want an image on the right, perhaps you want no images at all. It would be great if this drop-down component does not have any opinion on that and would be able to just render the items however you want at that particular location. Fortunately, you know exactly what to do here. Now, after this refactor, the component now takes a block. The block is called once in each iteration of the loop, and the item in question is yielded to the component, yielded to the block via block param. Instead of hard-coding how the item should be displayed inside a component, the markup now lives on the caller side inside the block. Now, the component doesn't care what the items are anymore, and you are free to display them however you want. All it does is takes care of the basic functionality of a drop-down menu and defer the rest to the caller to customize using a block. This is pretty awesome. So just when you are ready to celebrate and take an early lunch, a challenger has appeared. Turns out it was your PM. It turned out that he spotted a problem. Sometimes the list of items could be empty, in which case he wanted you to render a nice message with an explanation instead of just rendering an empty dropdown. Seems pretty reasonable, and in and of itself it's not that hard to implement. In fact, you can probably just implement it right away. You just need to add an else block to the each loop, right? That's pretty straightforward. Now the problem is though, this basically rolled back the work you did earlier to make the component reusable. You see, the component once again is hard-coded to this exact scenario thanks to the markup in that else block. If it were just a simple message, perhaps you can get away with taking it as an argument, but since this requires some non-trivial HTML, that doesn't really work. Oh well, maybe you have a better idea after lunch. Just when you're ready to take your lunch, your PM pinged you again, and turns out he just had a meeting with another PM and he showed off your work on the dropdown. The other PM loved it, and in fact they loved it so much that they wanted to use the space above your dropdown to show an ad. That's unfortunate, but oh well. Eat first, think later. Lunch time. So yeah, you took your lunch break and you had a generous portion of mashed potatoes. If that doesn't solve your problem, then probably nothing will. Okay, back from lunch, get stash, start over. Just before the food coma kicked in, you remember hearing about name blocks at the EmberConf keynote, and the presenter told a story that was oddly similar to your situation right now. So you decided to check that out. After looking at the documentation, realized name blocks is the perfect solution to your problem. It's like they were made for this exact purpose. This is what you came up with. Let's break it down. First, you define a name block for the ad called it the banner block. And on the caller side, you can pass the name block with the colon banner syntax. It looks like a regular HTML element, except it starts with a colon. That's how you know it's a name block. Inside the dropdown component, you can yield to this name block using the same yield syntax from earlier, but with the additional 2 argument set to banner, which is the name of the block. Down below, you have the item block, which is exactly the same content as before. Just like before, the block is still being called once per item and has access to the item in question as a block param, which is provided by the component by passing it to the yield keyword. Finally, you have a third block for the empty state, so the component doesn't have to hardcode anything there as well. Just like that, you have learned to use the name blocks feature, and in summary, it's just like normal blocks. You can yield and take block params as with normal blocks, and the only difference is that now there can be multiple blocks and each identified with a unique name. So when yielding, you would also have to specify the name of the block that you're yielding to. If you're already used to how blocks work in Ember, hopefully this would feel pretty straightforward and feels like a natural extension to that paradigm. Now that we've covered the basic use cases for the feature, let me walk you through a cheat sheet for the feature. First of all, this feature is only available for angle bracket invocations. There is currently no name block syntax for curly invocations. So if you want to use name blocks, you have to use angle bracket invocation for now at least. Next, while you can pass multiple blocks in the same invocation, as we saw in the earlier example, each of them must have a unique name, so you cannot pass the same block multiple times. Also, name blocks can only appear immediately inside an angle bracket component invocation, so you cannot have a name block just chilling out at the top level. And on the other hand, if you're going to pass name blocks, you cannot also have other content inside the invocation tag. Likewise, because you can only have name blocks immediately inside a component tag, you cannot pass name blocks conditionally. However, you can make the content inside of name blocks conditional as shown on the left here. On the flip side, inside a component, you can detect whether a particular block is passed to you using the hasBlock keyword. This allows you to make a name block optional for your consumers and provide some useful default content if the block is not passed. We already saw this story earlier, but just as a regular block, your component can yield as many or as little block params to a name block as you would like. On the passing side, you can name them whatever you want, and they'll become local variables that are accessible within and only within the block. Not that you should ever write the thing on the right, but the anonymous block syntax that you're used to is actually a shorthand for the default name block. So again, there's generally no reason to do it that way, but knowing this might be useful in some tricky interop and backwards compatibility situation that you might run into. Likewise, the 2 blocks that you can pass with curly invocations is actually correspond to the default and the else name blocks. This might come into handy when there is a component that takes an else block, but you otherwise want to use the angle bracket notation to invoke it. So this allows you to do just that. And along the same lines, on the yielding side, the default yield syntax is the same as explicitly yielding to the default block. Again, there's no good reason to write it out like that, but knowing this might help you design a backwards compatible component that can be used with or without the name blocks feature. So that's all I have for the name blocks feature, and we have already started using this in a few places in our app at work, and I would certainly have designed some of our components differently if this feature were available earlier. Even though the feature is pretty simple to use, it unlocks some pretty powerful patterns for components, and I can't wait to see what the add-on community comes up with. Okay, so moving on, the third and final feature I want to highlight doesn't really have a name, so let's just call it template value semantics for now. It is definitely a more advanced set of features, so please bear with me. So here I have a hypothetical form component library and a form implemented using that library on the screen. The form component takes a block and yields a block param, which we named f. Inside the block, you have access to the form controls provided by the component using the f block param. You can invoke them like f.input, f.textArea, and so on. You have probably seen something like this in an add-on before, but maybe not everyone knows exactly how that is implemented under the hood, so let's take a look at that. Now, if you open up the source code of this component's template, it will probably look something like this. The block param it yielded is actually a hash, and each item in the hash corresponds to one of the form controls that you have access to inside the form component. It uses the component helper, which allows you to refer to and look up a component in your app or your add-on by name. In this case, it's the actual definition of the f.textArea component we saw earlier actually lived in a file called myform/textArea. In addition to letting you refer to a component by name, the component helper also serves a second purpose, which is to allow you to pre-configure the component by pre-applying some arguments. In this case, we specified an argument called form and assigned the value to this. That means whenever someone invokes the f.textArea component, it will automatically pass this extra argument to the component as if the caller had specified it in the invocation tag, even though they didn't. This pattern that we're seeing here is called Contextual Components, where you can use the component keyword to gather a bunch of your components, pre-configure them, and yield them out to the caller. Usually these components you're yielding aren't meant to be used standalone, and they only really make sense in a specific context. In this case, the form controls are only meant to be used inside the context of a form component, and that's why the pattern is called Contextual Components. And by the way, even though the pattern is usually done by grouping all the related contextual components into a hash, there's nothing intrinsically special or requires the hash keyword. You could have done the same thing by yielding the contextual components as positional block params, and as you can see, this still works without the hash keyword. However, by yielding the component one by one, the caller would have to remember to bind all the block params in that exact order that you yielded them. That's why usually it's better to yield a single object that has everything in there keyed by the appropriate names. Still, the hash keyword here is not special or required. You could have made a POJO in JavaScript and yielded that out instead, and it would work all the same. Okay, so since we just talked about name blocks, you might notice that there are some superficial similarities between name blocks and contextual components. In fact, because we didn't have name blocks in the past, until very recently at least, some of the roles that would have otherwise been more naturally filled by name blocks were sometimes historically implemented using contextual components because we don't have anything else. However, now that we have both, they actually serve pretty different purposes, and it's not like one is replacing the other. On the one hand, when using a name block design, the component author has total control. You can decide exactly when to call which of the blocks, and you can call block 0 times, 20 times, completely up to you. You can choose to pass additional data to the block in the form of block params, and on the other hand, when using a contextual component pattern, you are giving the control to the caller of the component instead. You can yield as many contextual components as you like, but there's no guarantee that the caller will call them at all or in any particular order. So, and also instead of you passing data to the caller will be passing data to your components instead by passing arguments. In other words, the difference is I call you versus you call me. And in the drop-down example, there can only be one banner, for instance, and it has to appear exactly at the top of the drop-down menu, so it wouldn't really make sense for that to be contextual components, because otherwise you can call it in any place, you can call it many times. That wouldn't make any sense. On the other hand, in the form example, you want the consumer to be able to design your form by mixing and matching your form controls arbitrarily in any order or combination. So the contextual component approach makes total sense there. Okay, so even though it's pretty advanced, contextual components are actually a pretty old feature of Ember dating back to Ember 2.3. So why are we talking about this right now? Well, until now, you can only have contextual components, but as of 3.27, which again is currently in beta, you can also have contextual helpers and modifiers thanks to the new modifier and helper keywords. This works exactly the same way as the component keyword by taking the name of the modifier or the helper as a string and returning a value representing that modifier or helper. As with components, the most common thing you want to do with it is probably to yield them out in a contextual fashion. But because it's just a regular value, you can actually do whatever you want with it. You can, for example, pass it to another component as an argument if the component accepts a helper or modifier for one of its arguments. And just like the component keyword, you can use the modifier and the helper keyword to pre-configure things by pre-applying certain arguments to them. These arguments will then be baked into the value returned by the keyword so that when someone tries to invoke it later, the modifier or the helper will automatically receive those extra arguments as if the caller had provided them. Again, this works exactly the same way as the component keyword. On the other hand, this is what it will look like to invoke one of these values, very similar to the example before. Now, this feature opens up the possibility for a completely new category of component composition patterns. For example, in the hypothetical form library, we can yield an auto-resize modifier that you can attach to any of the text input and have them automatically grow and shrink as the user types in them. It can also yield a collection of helpers for declaring validation rules right inside the form template instead of having to do it in JavaScript. And yeah, contextual components are probably one of the most powerful template features in Ember. And when it became available, it opened the floodgate of a lot of interesting component designs. And I'm hoping that this will be the same. And again, I'm really looking forward to seeing how you put this feature to use. Okay, so that's pretty exciting, but that's not it. In addition to the keywords to create a value referencing a component, a modifier, or a helper, we also overhauled the rendering engine to accept them as values in a lot more places than it used to. For example, here we imported a component, a modifier, and a helper from an add-on, and we assigned them as class fields. This allows us to access these imported values from within the template, and if we tried to invoke them, this didn't used to work, but now it does. Everything just works as you would expect. Again, all you did was importing a component or a helper or a modifier, and if you have access to them in the template somehow, then you can invoke them all the same. As you can see, in this case, you don't even need the component keyword anymore, or the helper keyword or the modifier keyword. Of course, you can still choose to use those keywords to attach additional arguments to your imported values if that's what you want to do. This works exactly as you would expect as well. That opens up some pretty interesting possibilities. For example, you can define a helper function in the module scope of a component JavaScript file, attach it to a class field, and that allows you to create a truly private one-off helper specific to this component without having to registering it and leaking it into the global namespace. You can even dynamically create one-off modifiers that capture tracked instance state inside a getter, and as always, the getter will be automatically rerun and therefore returning a new modifier, replacing the old one whenever any of the track state changes. These patterns are pretty powerful, and I think they will open up a lot more use cases that are previously either very cumbersome or even impossible. I know I've said this a bunch already, but I'm really looking forward to seeing what the next generation of Ember add-ons will look like. Before we close off on this topic, there's an elephant in the room that I need to address. Going back to this example that we saw earlier, it's pretty cool that you can do this, I guess, but having to import the values into JavaScript and then make a class and then assign them to fields just so you can have access to them inside a template, that feels like a lot of boilerplate. Especially when you otherwise wouldn't have needed a JavaScript class, and like if you would have been able to get away with a template-only component, this seems like a lot of work. Wouldn't it be great if you can just import those values and use them in the template directly? Well, good news, template imports allow you to do just that. And it's exactly the direction that we're iterating towards. This example doesn't work yet, and this is probably not going to be the exact syntax that you would type in its final form anyway, but it's a good enough stand-in to show the direction that we're headed towards. The idea is that you would have to import everything that you use in the template just like you would in JavaScript, instead of having everything magically become available in the global scope. While this adds a little bit of a boilerplate, it makes it a lot easier and a lot clearer where your components, modifiers, and helpers are actually coming from. Not only will that help humans navigate an unfamiliar Ember code base, it will also make it easier for VS Code and other IDEs to provide tools like autocomplete, jump to definition, that kind of stuff. Plus, it will also help Embroider to see what you're actually using and not using in your app, so it can remove any unneeded code from your final bundle in the tree shaking step. The design for template import syntax haven't been finalized yet, so that's why the feature have not been implemented yet. However, we're doing things a little bit differently this time. Instead of waiting to finalize the user level syntax, we designed and implemented the underlying low-level primitive that is needed to provide the functionality. That primitive have already landed in recent versions of Ember, so thanks to that, we are currently able to experiment with different syntax ideas in an add-on called Ember Template Imports. If your app is running on Ember 3.25 or above, you can install the add-on today and start getting a feel of what the future would look like or feel like. One of the current design exploration is to see if we can find a good syntax for embedding the template into JavaScript files directly. And the template would have access to any values that are available in the outer JavaScript scope. This would make it much easier to do the one-off private helpers kind of thing that I showed earlier, but there are still a lot of open questions to answer. Would this be ergonomic? Is this going to feel awkward? Is it possible to get good syntax highlighting and editor support? And what should the file extension be for this kind of hybrid files? These questions would have been quite difficult to answer without being able to experiment with the feature hands-on. And thankfully, the experimental add-on allows us to do just that. As I said in the beginning, we are approaching the pit of incoherence. A lot of things are still in flux, but that also means that right now you have a lot of influence on how these things shapes up in the next edition. So if you want to hear more about template imports, there was a BonusConf talk on that topic yesterday, which should be available on YouTube soon. Follow the EmberConf Twitter account so you won't miss it. Okay. So that was it for the highlights, and before we wrap up, here are some of the new primitives that we have landed in the past year. Because these are primitives, you're not expected to have to know about them, and it's unlikely that you will use them in your app directly, so I'm not going to go through them. However, if you're an add-on author or an experimenter, these are the RFCs to read. For instance, RFC number 496, strict mode templates, is the underlying primitive that was used by the template imports experimental add-on that I showed earlier. So with that said, we also made some process changes this year. Let's see. RFC 627, for instance, revamped the RFC process itself with the goals of making the process more agile. 649 aims to make the deprecation rollout process more gradual and incremental. 685 defined the browser support policy for Ember 4.0 onwards, notably dropping IE11. The polyfills and the code mods are also now more of an official part of our process. We have centralized GitHub orgs for each, and we strive to provide them like for any new features and deprecations that we release whenever possible. The accessibility track team also graduated into the accessibility working group, which is a more like and they have a more permanent mandate. You can thank them for spearheading the accessibility efforts, such as the page title and length flag that I mentioned in the beginning, and they have more work in flight, so stay tuned for that. Meanwhile, we have also formed a TypeScript track team to shepherd the effort of official TypeScript support. Right now, you can already use TypeScript with Ember, and it works pretty great. We use it at work. It's perfect. It's great. The community did a really good job supporting that effort. But by making this more official, we hope to provide a more seamless and more stable experience for all the TypeScript users that along the same lines that you would come to expect with the Ember project. Finally, with things like template imports on the horizon, we would need to ramp up our tooling effort. And to that end, there's a new Dev Ember tooling channel on Discord. If you're excited about template imports, for instance, and want to help build a polished developer experience, that would be a great place to start. Finally, that brings us to my last point. From testing out Embroider, trying out Polaris features, and providing early feedback for all of these, helping build the tooling support for template imports, to filing bug reports and answering questions on Discord. I hope I have inspired you to find some avenue to get involved in the community. And hopefully we'll be able to meet in person again soon enough. But until then, enjoy your virtual EmberConf experience and see you on Discord. Thank you.